Nowadays, computers are literally everywhere, on your desk, in your backpack, or even in your pocket. But when we think of a computer, we tend to imagine a metal box packed with rocket science and alien technology, and this is actually not true. The brain of a computer is packed with a bunch of transistors doing very simple things. You can imagine a transistor to be a gate which blocks or opens a way for information to pass through. A large enough bunch of these forms what sits in our computer, allowing us to do anything, from launching a nuclear missile to catching a Pokemon. To make our computer more and more powerful, these transistors are made to be smaller and smaller so we can have more of them in our computer chip. However, when transistors are shrinking to the size of only a few atoms, they stop functioning properly. This is because our physics works very differently in the quantum realm. As a result, scientists are trying to use these quantum properties to solve this problem by building quantum computers. In traditional computers, information is represented in bits, which can be set to either 0 or 1. But in quantum computers, information is represented in qubits, which can also be set to one of the two values. However, unlike traditional bits, a qubit can be in both states at once as long as it is not measured, which is called superposition. Once a qubit is measured, it will fall into one of the basic states. To understand why qubits are better, let's compare traditional bits and qubits. For traditional bits, a combination of many bits can only store one of the possible values, but for qubits, as long as they are not measured, a combination of many qubits can be all of the possible values. It means qubits can store much more values than traditional bits. While normal computers use logic gates, which receive bits as input, perform logical operations, and produce one bit as output, quantum computers use quantum gates, which receive a set of superpositions of qubits as input, perform logical operations, and produce another set of superposition or entangled superposition, or both as output. You can imagine a set of entangled qubits to be multiple births like twins. Once you measure one of them, you will know what another is. This means while a normal computer has to do all calculations one by one, a quantum computer can finish all of them at once. But because the information stored in qubits will be lost once we measure it, we can only measure it once. So quantum computers are only much faster when doing certain calculations, and showing cat videos on your screen is definitely not one of them, so they won't replace your crappy computer in the near future. However, when all possible results of a calculation are needed, they are incredibly fast. One of the examples is database searching. A normal computer has to look through all the items one by one until it finds the right item, while a quantum computer only needs a square root of that time, which is significant in very large databases. Another example is quantum simulation. Simulating quantum physics can be a very tough job for a normal computer, and the result is often not very accurate. So using actual quantum physics to simulate quantum physics is obviously a better idea. In fact, Google has accurately simulated a molecule in a quantum computer, which is not possible in a normal computer. If this trend continues, we can see a big advancement in everything from solar cells to medicines in the near future. The most famous use of quantum computing is ruining IT security. Right now, all our sensitive information stored in our computers are protected by encryption, which will make your information meaningless to the others. To retrieve the original information, you will need to provide the master key like password. For a normal computer to find the master key without your permission, it has to try every possible combination or do very complicated math until it finds the correct one, which might take hundreds of years to do so. But this process can be shortened exponentially in a quantum computer, which might take only hours or even minutes. Before you get too excited, quantum computers are actually still in its infancy. In the latest Gartner Hype Cycle report, quantum computing is still under innovation trigger stage, which is a fancy name meaning it has the potential to be a big thing, but no usable product has been released, and it might need more than 10 years to be stable enough in the market. Currently, quantum computers are mostly under research and development stage, and most of them are far from taking full advantages of quantum physics. This is because qubits are extremely sensitive to the environment, and fully make use of superposition and entanglement is extremely difficult. But if considering how fast our normal computer has grown, it's no doubt that quantum computers will see the light at the end of the tunnel very soon.